All right, so we're going to continue with the lesson for the homework due April 10th. Okay, moving on. So a segment or line segment is the part of a line consisting of 2 points and all the points between them. So right here is a segment. It is different than a line because it has 2 endpoints. Here you can see it's point A and point B. There are no arrows at the end, which means this does not go on forever. To describe a segment, you would describe it by its 2 endpoints or 2 points. So I could describe it as AB or BA. And then you just draw a line above it. No arrows. Okay? As I just talked about with the endpoints, an endpoint is a point at one end of the segment or the starting point of an array. So here, I'm going to move myself up there. You can see that C and D are your endpoints. When describing endpoints, you would just say C and D are endpoints. Write it like that. Now, array. Array is a part of a line that starts at an endpoint. So you can see it's starting at an endpoint and extends forever in one direction. So it kind of looks like a segment and a line put together. But you have an endpoint and extending forever in one direction. This is another array. You have your endpoint, R, extending in one direction. When you're describing or naming an array, you would always put it in order from its endpoint. So here you can see its endpoint is R, and the array is going this direction towards S. Okay? Now, opposite rays. Those are two rays that have a common endpoint and form a line. So, if I look at this, if I disinclude this part, I can see that I have a ray starting at E and going to my left to F. I can see I have another ray starting at E and moving to the right towards G. These are two different rays, but they have the same endpoint E going in different directions. So when you write it, I could write it as EF, because I'm starting at E and moving towards F. And I can also write it, my second ray, as EG. I'm starting at my endpoint E, and I'm moving towards G. So you can notice when I'm writing it, on top, I draw a ray. E is my endpoint. It's always going to be where my endpoint is, and F goes along where it's going forever. So let's look at the differences between all the symbols. I'm going to move myself down here a little bit. So if I'm talking about a point, I see that this is my point. I can describe it as P or point P. Now a line. A line is always described by 2 points. In this case, it's A and B. We know this is a line because it has arrows, which tells us it's going on forever. When I want to describe a line or name a line, I would write it as AB, those 2 points, or BA. And notice I put a line above it with the arrows. Now looking at a line segment. We know this is a line segment because it has 2 endpoints. It does not go on forever. When we want to name or describe this line segment, we could write it as XY, which is the 2 points that make up the line segment, or YX. Notice that here there are no arrows at the end. That's how I can differentiate. If I look at this right here, I know that I'm talking about a segment because there are no arrows at the end. If I look over here, I know I'm talking about a line because there's arrows at the end. Now, array. You can see that there is one endpoint, and then it goes on forever. My endpoint is P. So when describing that ray, I always start with my endpoint. In this case, it's P, and it goes on forever, moving towards the point of Q. Notice what I put on top of there is a ray. What I put on top of there is a line segment, and what I put on top of there is a line. Now a plane. It is a flat surface, okay? And it's always described by 3 points or by the italicized letter that is describing the plane. So I'm going to move myself up here. So the three non-coplanar points, I could say it's plane EFG, or I could just call it plane T because it's italicized, which tells us that is the name of the plane. All right, so naming. Let's just look at differences. So I see that this is a line, this is a ray, and this is a line segment. When I want to name a line, as you can see, there are 2 points, A and B. I know it's a line because it has the arrows. And when writing or describing or naming it, I could write it as AB with a line over, or I could write it as BA with a line over. A ray has a point, an endpoint, and then it goes on forever in one direction. Here I know my endpoint is P, so I'm going to put that right there. And then my other point is Q. I draw the ray above it, knowing that my endpoint is near the endpoint of the ray that I drew above it. A line segment. I know this is a segment because there are no arrows at the end of this line. So I'm going to use the 2 points here, the 2 endpoints, to describe the segment, which is XY, or I could say YX. On top of it, I just put a segment or a line with no arrows. That's how I know to differentiate between these two. All right, so which of these is a line segment? I'm going to kind of move, oops. So if I look over here at B, I know that there are 2 arrows at the end, so I know that's a line. In C, which we'll talk about a little later, I know that's an angle because if you look at it, which we're going to talk about angles later, but if you look at this, there are 2 rays. 2 rays form an angle. I see 1, 2. There's an endpoint that goes on direction and another endpoint that goes on infinity in one direction. Now right here, I can see that this is a line segment. There are only 2 endpoints that do not go on forever. Drawing segments and rays. So I can see that this is, I know it's a little blurry, but I want to draw this ray, QR. So I know if I want to draw it, that Q is going to be my endpoint, and it's going to go on forever towards the point R. So if I had to draw this, it would look something like this. Q being my endpoint. So a segment with endpoints M and N. You can see I know I'm drawing a segment, and I know my 2 endpoints are going to be M and N. The next one, opposite rays with a common endpoint T. So we know there are rays that go in 2 different directions, but they have the same endpoint. So you have a ray going this way and a ray going this way, but both of them have the same endpoint. All right. A ray with endpoint M that contains N. So here's M, the endpoint, and here is N. So we know M is the endpoint, but it contains the point N. A postulate. So we're going to be working with the word postulate a lot. We're going to learn new postulates, but a postulate or axiom is a statement that is accepted as true without a proof. So we know that this statement is going to be true. Later on in geometry, we're going to be working with proofs. So we have to prove that that statement is true, but here we just know it is true. We don't need to prove anything. So postulates about points, lines, and plane help describe geometric properties. So here are postulates. Here are things we know are true. So through any 2 points, there is exactly 1 line, like we've been seeing. We always had 2 points, and we were always able to draw a line in between 2 points. Another postulate, through any 3 non-collinear points, there is exactly 1 plane containing them. So if I have 3 points, I know I could, if I wanted to, draw a plane around 3 points. There's always going to be a plane contained around 3 points. There could be more than 3, but 3 is the least number you need to have to create a plane. Now, if 2 points lie in a plane, then the line containing those points lies in the plane. So if I have 2 points in the plane, we know that it will create a line. 2 points always create a line. So then we know that those 2 points and that line lie in the plane. So whatever 2 points you're ever given, if you put them together, there's always a line that goes between them. If 2 points are in a plane, then there is a line in the plane. And we're going to get into more of this later on in the course. Another one, if 2 lines intersect, then they intersect in exactly 1 point. So if I have a line going this way and a line going this way, we know that they're going to cross paths at exactly 1 point. And if 2 planes intersect, then they intersect in exactly 1 line. So let's look at this. Sketch 2 lines intersecting in exactly 1 point. So if I know that this is 1 line and this is 1 line, they're always going to intersect at just 1 point. Always. Okay. Sketch a figure that shows a line that lies in a plane. So if this is a plane here, I know it's a little cut off. I want to sketch a line that lies in the plane. So I drew a line in that plane. So that is everything you're going to need to know for this homework. If you need help, please reach out to me. Please email me. I'm here to help you.